We have two equilateral triangles. One has a side length of 5 and the other 2. The bottom sides of both triangles lie on the same straight line. In the beginning, vertex C prime of the small triangle touches vertex B of the large triangle. Then, the small triangle starts to slide to the right along their common shared bottom edge. As we can see, in the beginning, the overlapping area of the two triangles increases until the distance traveled by the small triangle reaches 2, at which point the small triangle will be completely within the large triangle, and remain so until vertex C prime touches vertex C, at which point the distance traveled by the small triangle will be exactly 5. To recap, for distance traveled between 2 and 5, the small triangle will be completely within the large triangle. As the small triangle continues to slide to the right, the overlapping area starts to decline until the distance traveled reaches 7, at which point the small triangle will be completely outside of the large triangle again, and the overlapping area will be 0. So, if the distance traveled is x, how can we find the overlapping area of the two triangles as a function of x? We will solve this problem based on the 3 scenarios we just observed. In the first scenario, the distance traveled by the small triangle is less than 2. The overlapping area is the equilateral triangle DBC prime. It is equilateral because all of its angles equal 60 degrees. The length of its side BC prime is simply the distance traveled by the small triangle x. So, based on the property of equilateral triangles, the area of overlap, or the area of triangle DBC prime, equals square root of 3 divided by 4 multiplied by x squared, where x is the side length of equilateral triangle DBC prime. The second scenario is the easiest. When the distance traveled is between 2 and 5, the overlapping area is simply the area of the small triangle. Since its side length is 2, its area equals square root of 3 divided by 4 times 2 squared, which equals square root of 3. That's pretty straightforward. In the third scenario, the distance traveled by the small triangle is greater than 5 and less than or equal to 7. The overlapping area is once again an equilateral triangle, this time DB prime C. What's the length of its side, B prime C? We know B prime needs to travel 7 from its original position to reach C. Since it has already traveled x, it still needs to travel 7 minus x to reach C. So the length of B prime C is 7 minus x, and the overlapping area equals square root of 3 divided by 4 times 7 minus x, together squared. And that is all. If you enjoyed the content, please like, subscribe, and comment. Now go enjoy life.